What's up, guys and gals? It's me again. Wanted to do a video to help you guys when you're looking at an amplifier to actually determine best case scenario what the maximum power that amplifier can produce is. Because a lot of times you see these ads where they say an amplifier can produce 3,000 watts and it's like $100, and you're wondering, can this amplifier truly produce 3,000 watts? And probably not. So what I'm going to do is I'm going to give you a simple way to see if that's true or not. Now, a couple of things that you might want to know is there are different classes of amplifiers, and they vary in what they're able to do, what frequencies they can produce, and how they reproduce power and their efficiency. They've got Class A amplifiers, which are your least efficient. Then you've got Class AB amplifiers, which are more efficient, around 70% efficient. And then you got your Class D amplifiers, which are what most of your subwoofer amplifiers are in their Class D, and they have around 90% efficiency. Okay, now there are two types of power that we need to understand too. There is your input power into the amplifier and the output power of the amplifier. And that's how we determine efficiency. You've got an amplifier, and you're going to put power into it, and it's going to put some amount of power out. And since there's no amplifier that's 100% efficient, this number going in is always going to be greater than the amount of power that you get out. But if we want to determine the power of an amplifier, what we can do, an easy way to do it, is take a look at that amplifier and look at the fuses on the amplifier. That will tell you how much power that amplifier can produce, and I'm going to show you why right now. Okay, the power equation that we need to look at is power equals, in the equation they say E times I, but E is the same thing as voltage times the current. That's your input power to the amplifier. So this voltage right here is either going to be 12 or 14 volts, and what determines that is if the car is started, your alternator is powering the system, your system will be at 14 volts. If you have your car off, it's at 12 volts because it's just running on the battery. So take a look at the amplifier and look at the fuses on the amplifier. So say you've got an amplifier and you look at the side of it and it's got two 25 amp fuses on it. Like that. That's the maximum current that this amplifier can draw. So these fuses are going to be in parallel. So the maximum current that this amplifier can draw on its best day is 50 amps. So what we can do is we can plug that 50 amps into the power equation. So what we can do, power is going to be our voltage. Let's say that the car is running. That's 14 volts from the alternator times the maximum current, because it can't, this amp can't draw any more than 50 amps because it's going to blow these fuses. That's why they're there. So it can't draw more than 50 amp. So 14 times 50, let me get my calculator out. So we got 14 times 50, 700 watts. That's going to be your maximum RMS power for this amplifier on its best day. So if you see an amplifier and they say it'll produce 3,000 watts and it's got two 25 amp fuses, you know that that's not true. It is no way possible that it can, at 14 volts, produce 3,000 watts RMS, which means it can continuously produce that power all day. It might, when the planets are perfectly aligned and all is good in the world, produce 3,000 watts if you chunk 18 volts into it and tons of current, but the amplifier would probably be destroyed when you did it. But for RMS power, this equation right here is telling you what the RMS power of that amplifier can be on its best day. And they're not arguing with you, they're arguing with Ohm's law, and Ohm's law cannot be violated. The maximum power that the amp's going to produce is 700 watts. So that's with the car running. So let's say you cut the car off. This is now sitting at 12 volts. Okay, so do it again. 12 times 50, that's going to be 600 watts. So when the car is not running, the maximum voltage that that amp is going to be able to produce is 600 watts RMS on its best day. Okay, so when you see amps like this, that's a good way to tell if they're giving you true numbers or not. So let's take a look at my amp and see, are they being honest? Oh, I forgot to show you about efficiency, but we'll do the efficiency calculation on my amp. I run a Soundstream EGA 1700D. I actually run two of them, but each one of them is has 530 amp fuses in parallel. So my amp at 14 volts can produce or will draw 150 amps of power. It's got 530 amp fuses in parallel. So let's see what the maximum voltage that my amplifier can produce. So if we do 14 times 150, that's 2100 watts. Now my amplifier is rated at 1700 watts RMS. Okay, so now remember, this is maximum power. This would be if the amp was 100% efficient, but it's not, because all of this power right here that you're putting into the amp has to go through transistors, which get hot when they produce current, and heat means you lose efficiency. And when that happens, that heat is being given off, and that's part of your power. You know, a 60-watt light bulb produces heat. That's because it's losing 60 watts of heat. Okay, so let's say that since my amplifier is a Class D, it's 90% efficient. So what we can do is we can take this 2100 watts and multiply it by 90%. So let's do that and see what happens. $2,100 times 90% efficiency, 1890. So we can see that at 14 volts, my amplifier is probably producing around 1800 watts. So I know that Soundstream is being honest when they tell me that this is a 1700 watt amp. So that's how you pretty much tell what an amplifier is able to produce. Okay, so let's see where they got this figure from. That's why it's important to see whether they took that rating at 12 volts or at 14 volts. Okay, so let's see what my amplifier is able to produce at 12 volts when the car is not running. Alright, so we got 150 times 12, that's 1800. Okay, let's do it again. Let's multiply it by the efficiency of 0.90, 90% efficient for Class D amplifiers. 1620. So 1620 volts. So we know that this amplifier will produce somewhere between 1600 and 1890 watts, which is right about what Soundstream says. So they're not trying to be fictitious with their rating. And that makes me feel more comfortable with them as a company, because they're not trying to sell me a 3000 watt amp that will really only produce 700 watts. But that's how you do it. Take a look at the fusing on the amplifiers, multiply that by 14, and that'll give you a pretty good feel. And then you can multiply that by 90% to see actual power, because it is going to lose power when it goes through the transistors. But that's how you tell if somebody's not telling you the truth or not.